Hello students, so today we are going to discuss here electrostatic potential. Okay, so potential you learn in the what is the potential energy in the center of the gravitation, that the potential energy is the energy because of the position of an object, and there you learn that the potential energy is equal to mgh at the height h. But here we are going to discuss the potential energy because of a charge system. And what is the potential energy? So here is also, energy can neither be created nor be destroyed. So from where this energy comes, this concept comes, the energy is stored to bring the charge from the infinite position to a given point in an external electric field. That will be the potential energy. This is the test charge Q naught at the infinite. Why we are choosing here the reference point at the infinite? Because at the infinite there are no attraction from the other charge, and we can assume the initial potential energy of this charge is the 0. Okay, so we choose in here the infinite position. So work done to bring the charge, this is the positive charge and this is also the positive charge. So what is the condition? The work done to bring the slowly, not this should, the motion should not be accelerated motion. Work done to bring the charge from the infinity to a given point is called the potential energy. Okay, and what is the expression for the potential energy? The expression for the potential energy is that U is equal to integration of minus Q into E into dx, limit from the infinity, initial infinity to the position R, infinity to the position R, oblique infinity to the position of X. Okay, minus sign here indicate that the you need to hold this charge. Okay, this you need to work done on the system. So that's why it is the minus with the charge and the minus with the minus sign here. So this is the potential E is the for the electric field. So this is the potential energy. Okay, potential energy. And if I'm talking about the what is the potential, electric potential only, what is the electric potential? So work done to bring a unit charge. Unit charge is 1 coulomb of the charge. 1 coulomb charge, work done to bring the charge of 1 coulomb from infinity to a given point is called electric potential. And the expression for the electric potential is V is equal to 1 coulomb. That means you can put the value of Q is equal to 1 coulomb. If we choose the value of 1 coulomb, so this expression becomes infinity to x minus E into dx. Okay, this is the electric potential only. Okay, here you can see, you can also write here in the other form कि E is equal to, you can write here minus dV upon dx. E is equal to minus dV upon dx. Okay, change in potential. And what is the here negative sign? The negative sign indicate here the direction of the electric field is in the decreasing order of the electric potential. That means you can choose if it is the, this is the electric field, direction of the electric field. If I am asking you there are 3 points A, B and C. So at which point the electric potential will be the high? You know the electric field, electric potential will be the decreasing order of the electric field. So at the A point you can say the point A will have the highest electric potential, because electric potential will be in the decreasing order of the electric field. So electric potential is the work done per unit charge. You can see your work done to bring a 1 coulomb of the charge. Okay, electric potential is a scalar quantity. Electric potential is a scalar quantity. Electric potential is a scalar quantity. Okay, that means if you want to find the electric potential because of the number of the charges, you can no need to take any direction, no need to take consider the vector addition. You can directly sum up. Like see, if I'm asking what is the electric potential because of a point charge Q at the distance, this is the point charge. What will be the electric potential at point P? because of the this charge point Q. So because of the one point charge, electric potential V will be equal to, if this distance is the R. So expression for the electric potential V is equal to KQ upon R. This is the electric potential because of a charge. If this V will come with the sign of the charge. If this is the minus negative charge, what will be the electric potential at the point P from this distance R? The V will be equal to minus KQ by R. This is the electric potential because of a point charge. And what will be the electric potential because of the system of the charge? If there are two charges. System of the charge. Like see, if we are saying this is the Q1 and this distance is the R1 and this is the Q2 and this distance is the R2. So we know electric potential is the scalar quantity. So there will be electric potential because of the positive charge Q1 and there will be the another electric potential because of the positive charge Q2. So what is the net? Suppose this because of the Q1 the potential is the V1 and because of the Q2 the potential is the V2. Okay, this Q1, because of this Q1 charge, if the potential is the V1 and this Q2 charge, if the potential is the V2. So what will be the net potential? Net electric potential Q2. So net potential will be equal to scalar, because potential is the scalar quantity. So this is the V1 plus V2. That means KQ1 by R1 plus KQ2 by R. Okay, and if I am talking about the potential energy, what will be the potential energy between two charge particles? The potential energy between two charge particles is, like if this is the Q1 and this is the Q2. So what is the potential energy between two charge particles? Between two charge particles, if they are at the distance of the R, the potential energy U will be equal to K Q1 Q2 by R. This is the potential energy because of the two charge system. Okay, and if there are more charged particle, so how can you explain? So you know what is the that the potential energy is the work done to bring the charge from the infinity to a given point. So suppose there are two charge system. Now I want to make a charge system. I want to bring here the Q3 charge. So this become a system of the three charge particle Q1, Q2 and Q3. Okay. So what will be the potential energy of this charge system? The question may be asked, what energy is needed to construct this system? Second question may be asked, what energy is needed to separate this charge? That means to take all these charges at the infinite position. So two type of the question may be asked. So how can you understand this situation, students? So you can understand it like see, if you are bringing, this is the initially, if you are bringing this charge from the infinity to a given point, so there are no other charge particle in this plane, so no other charge will be repel it, no other charge will attract it. So work done will be equal to 0 because no force is there, no electric field is here. So no electric force will be there, and work done to bring this charge from the Q1 charge from infinity to a given point, the work done will be equal to 0. Work done 1 will be equal to 0. And now if we are bringing the another charge Q2 from the infinity to a given point, this point, we are bringing this charge Q2 charge from the infinity to this point at the distance R1, position vector is the R1. So what will be the potential energy, what will be the work done? That the work done will be stored in the form of here potential energy. That is this charge is the Q2, so work done become equal to K Q1 Q2 by R1. Okay, and now if we will bring the third charge particle Q3 from the infinite to a given point, if we are bringing, then this charge will repel to this Q3 charge and this Q2 charge also repel to this Q3 charge. So both charges will repel, so you need to work done again these both charges. These both charges. So when Q3 you will bring here, so there will be a potential energy between Q1 and Q3, and there will be a potential energy between Q2 and Q3. Okay, so let's see if this distance is the R3 and this distance is the R2. So what will be the potential energy between Q1 and Q3? So that will be equal to what? K Q1 Q3 upon R3, and between this Q2 and Q3, K Q2 Q3 upon R2. Okay, and what will be the total work done? The total work will be equal to what? The individual work of this all charges. So the total potential energy become equal to total potential energy. It become equal to what? W become equal to K Q1 Q2 upon R1 plus K Q1 Q3 upon R3 and plus K Q2 Q3 upon Q2 plus K Q2 Q3 upon R2. Okay, and suppose there are n number of the charges. So how can you find? You can find like this. If there are n number of the charges, you need to add that all the charge, the individual pairs. Suppose there are 4 charge systems. This is the Q1, Q2, Q3 and Q4. I'm asking you what will be the potential energy. This is the distance R1, this is the distance R2, R3 and R4. So what will be the potential energy of this system? So the potential, there will be a potential energy between Q1 and Q2, second potential energy between Q2 and Q4, third potential energy between Q3 and Q4, and fourth also. You can check here, you can see there are some more pair you can make. So what will be the more pair? There will be a pairing between Q2 and Q3. There will be a pair between Q1 and Q4. So if you will add all these potential energy, these pairs, then this will be the net potential energy of this system. Okay. So hope you can find the potential energy of the any kind of the charge system. Okay. So thank you. We will meet you in the next class.